talk by Armelline about expressions in game salad. Not to be in notes, but I will have Code Wizard on the line if you guys have questions after the talk about that. But let's first, after the presentation, have any questions to Armelline out of respect first before we start diving into many questions people may have about game salad. We'll have a meeting next month. Sorry we missed July. Lots of things got busy here. So other than that, I'll go ahead and turn it over to Armelline and let him go ahead and start his talk about expressions.
Thank you. Okay, I'll warn you first that I've had to shut my cat in because she's mouse hunting, so she's very annoyed. So she might disrupt us as much as she can. I'm going to be talking today a bit about the expression editor. I'm going to be looking at quite a lot of examples using game salad itself, but for some of the simpler ones, I'm just going to skip through quite quickly on the presentation. We're going to be looking at a bit about maths, concatenation, which I'll explain what is, quotes and spaces, and order of operation. We're going to look at all the reformatting options, which are quite simple, and we'll look at only quite briefly. Then we get into the proper maths of it, which is much more complicated, and the way of comparing. I've called it comparisons, but it's a bit more complicated than that. So I'm going to just start off by making a blank project and just show you what we mean by the expression editor. We're going to be getting into some maths. I'm not a mathematician. I'm not great with maths, so I'm going to be looking at it much more from the point of view of what result can we get in game salad from using these functions, rather than too much detail about the maths behind some of them. So if I just drop a display text onto the scene, game salad, as you will most likely know, is a very much drag and drop based engine. So most of what you want to do, you can do without really ever needing to type anything, without getting into very much maths at all. But when you want to do something beyond what the drag and drop can do, we end up going into the expression editor, and there's this quite long, daunting list of functions. I'm not going to touch on the network behaviors at all, and I'm not going to touch on the table behaviors at all today. If we get time, we'll go on to the text ones, but I think we probably won't have enough time. It's 1:12 for me here, so I'm not going to want to go on for too long. So a little introduction then, first of all, to the expression editor itself. This is where you can do maths. So if I want to say 10 plus 10, I'll have to drop this onto the scene. But we see immediately that we've got the result of that calculation. If you want to do slightly more complicated maths, you can do slightly more complicated maths. I'm not going to do very complicated maths here, but let's just add an extra little bit, and we'll see the result of that calculation. So the expression editor is great for doing simple maths, but we can also use it for displaying text in various formats. So if I want to say hello, I can open quotations, type the text I want to display, and close quotations. Now I could type it directly into the box here without the quotations, but if I want to do anything with the text, I'm going to need to be using the expression editor. So as you can see, we've got our hello. I'm just going to make this slightly bigger. And if we want to join together more than one piece of text, we can do so by doing two little dots and then type what we want to type. So we can then display that, and we'll see that it's just plonked the two things together and displayed them. Now I put a space in here, and if you try and press the space in Expression Editor, nothing happens. So you might get a bit frustrated by that. The way we get around that, if we want to just display a space, is by pressing Alt and space, and that will put in another character that looks like the space. So for most intents and purposes, it will work just fine to have it with the Alt and space. There are some considerations with the using of a space in Expression Editor. It isn't a space when you type it like that. So if you do a text comparison, it won't work. It will be looking for a different character to the space. And you can either put the Alt space in the other string you're comparing with, or you can make a extra attribute at the side that's a space and concatenate it on. So if I put a text and I just type in here space, and I go back here and now instead, if I add this attribute and 2 more dots, it should now display it with the space. And that's the first really powerful thing with the expression editor, is that we can be pulling in attributes from anywhere we want. So if I want to display let's say the position on the x-axis of this, I don't hope I've actually put it in, then we can display that as well by putting it into the expression editor. And so we're going to be doing quite a lot of that today and pulling attributes from self-attributes. You can do game attributes as well, but we're only going to need self-attributes for our examples today. So that's very basically what the expression editor is, but where we really get the power in it is from these functions in this big long drop-down list. Some of them are quite simple and some of them are a lot more fiddly and difficult to get what you want from, but we can do some quite powerful things with them. I should spend a moment talking about order of operations. There's a couple of links that I'm going to drop into the meetup thread tomorrow to so that you can visit them and look. If you're not familiar with BODMAS, it's not something that in England I learned under the name BODMAS, but we learn the same kind of things. And it basically means that the order of operations being used means that how you format your calculation matters. If you put 10 plus 10 times 20, that's not the same as opening brackets 10 plus 10 and times 20, because it will do the multiplications first and then the additions. But it will do what's in brackets before the multiplications. So when we say 10 plus 10 times 20, it's going to times the 20 by the 10, then add the 10. And if we say 10 plus 10 in brackets times 20, it's going to do that 10 plus 10 first, then multiply it by 20. So in the first case, we get the result of 210. In the second, the result of 400. Now, this may seem obvious, but it's very easy to forget when using the expression editor that this is happening. And a lot of the time when you think that what you've put in isn't working, it's probably, well, there's a good chance that it's just that you've not put brackets in the right places. And I tend to be excessive in my use of brackets too, because as I said, I'm not a mathematician. It doesn't come very naturally to me. So if I use brackets everywhere I want to be sure things are happening in the right order, even if they're not strictly necessary, I find that very helpful. So we'll look at some of the actual functions themselves. Oh, I've got my thing bouncing, I'm not sure why. We'll look at some of the functions themselves. The first one we're going to look at is abs. And for these quick, easy ones, I'm just going to look at them in a slideshow for a couple of minutes. All that does is it gives you the absolute value of a number. So if you've got a negative number, it will make it into a positive number. And the format is just abs, open brackets, number, close brackets. So just a couple of quick examples. You can see if you put -1 in, you get 1 out, minus 54.65, you get 54.65. If you put a positive in, it doesn't change anything. So this should show a thing. So a good, useful way of using it is it will let you work out the distance from a point without having to resort to magnitude, which we're going to be looking at a bit later. So since you're taking 284, we're subtracting the x position, sometimes we would end up with a positive number, sometimes a negative, but because we're ensuring that the position, the result of that is being given as a positive the whole time, it means we can see whether to the left or the right of the center, that is the distance that it is from. So that's abs. It's quite simple, quite easy, quite handy. Seal is simply the integer when you round it up. So if you've got a decimal place or any number of decimal places and you use seal, it will round those up no matter what it is. So if you've got seal 1.542, it's going to round up. But if you've got seal 1.2, it's also going to round up. And negative will round up as well. It's quite a handy one to be able to use if you're subtracting decimal places of life from the player, but you only want to display that they've lost a whole unit of life when they've lost the entire unit and not when they've lost a part of it. So, I guess I'm about there. So every time I click on the heart, it reduces it by a random amount from 0 to 1, but we only see the reduction on the user interface when it has gone below that value. So quite easy, quite a simple one. And floor is just the opposite. It will always round down. So if we're looking at floor 1.5, you would think, well, that would normally round up if you did a round because it's a 0.5, but it will always round down with floor. So that's handy just in the opposite direction if you want to be a bit less generous to the player and want to say as soon as they've lost any health from that unit of health, it's taken away from them. So a couple of quick, easy ways of using those. Padint and padReal are just ways of changing the way the number is presented, of what it looks like. So it would just, it won't change what the number actually is because putting zeros on the front or the end of a number isn't going to change what that number is, just how it looks to us. So it will display an integer with the, a number, I should say number there, with the specified number, integer with a specified number of digits. So padint number, total digits. Nice and easy, and I'm not going to go into the game and show you it because it's a very quick, easy one. So the total number of digits, though, will always be total number of digits will always be the number of digits in the number or greater. So if you put a 10-digit number in for number and then put 0 for total digits or 1 for total digits, you're still going to see the 10-digit number. So the result is basically just digits added to the beginning of the number until you've got the size of number that you want to display. padReal is basically the same, but since it's got decimal places, we're looking at how many digits we're going to add to the decimal rather than to the whole part of the number. So it'll be the number, the total number of digits, and the total that you want to have on the right of the decimal. So if you put padReal 9.104 and then say you want 10 digits in total, 5 of them must be to the right, it's going to make sure there are 5 numbers on the decimal, and then we'll add any remaining numbers to the whole number part of the number. So nice and simple there. Now, precision is where it starts to get a little bit more interesting, because precision, as I was putting this together, I was learning things about precision that I didn't know before, and I suspect that this is one that is very much underused. It displays a floating point number, so a decimal number, well, can be a decimal number, can be an integer, but will display a decimal number with the specified number of decimal places. So you're going to say number, then the number of decimal places to display. It can round up or down. I was under the impression that it just truncated the number, but it will round it up or down, and it will add digits to the end of the decimal to ensure the required number. But what makes it so useful and interesting is that it will return text. So if you try and run a text function like text substring on an integer or real number, it's going to say invalid. It won't let you do that. But if you run it through precision first, it will then let you pull out individual digits with text substring. So very handy. If we get time to get onto the text substring and things, I'll show you an example of that. If you want to see one at the end, even if we don't get time, we can do one quickly. But I'm not going to do that right now. So very handy one. It can be essentially used to turn a number into text to use those text functions on it. Really interesting one. I found that very handy in recent weeks. So if you say precision 1.54 and you say you want 6 digits in total, it will show you those 6. If you say you want only 1 digit, it will round it up or down to the relevant amount. So very handy one. Round is essentially taking an integer, a decimal, and rounding it to an integer. So rounding it to a whole number. So you just put the number you want to round. So round 10.1542 will just round to 10. No matter how many digits after the decimal, it will just round it to that whole number. And it will round up from 0.5 and down anything below 0.5. So round 2 is the same kind of thing, but will allow you to specify the number of decimal places. And it will return, what it returns is still a number, unlike with precision. So it will say, we can say padReal, sorry, I shouldn't say padReal, round 2, that should say, number, and then the number of decimal places to display. So round 2, 1.54542 will display 1.55. So it will round up and down as you would expect it to when you're rounding a number if you do it in your head or something. Now, power, we're getting on to some of the more involved ones now. Power, if you look at the third bullet point, is essentially that little hat type symbol that you might have seen. And it's, if you were to write 5 and then write a little 3 on the top right of it, that would be you saying 3 to the power of whatever you write. So it will return the value of the first input you give it to the power of the second input you give it. We'll skip over to Game Salad now and have a quick look at how we might use that. So what I'm going to do is I'm just going to make a rule, and my cat's come to try and get me to let her out, and I'm just going to add a integer attribute and remove this one so I don't confuse myself, and I'll say number, and here I'm just going to give us the ability to this is a slight bug in the current Game Salad which you guys need to look at. The new attributes not always showing up straight away, and we're just going to say add 1 to it each time we click on the actor. So when touch is pressed, we're going to add 1 to the actor, and we'll start off by just displaying that just so you can see what I'm talking about. So every time I click on the actor, it should, or why have I not got it adding 1? I'm not sure why it's not adding 1. Oh no, it was just deciding not to add 1 then for some reason. So every time I click, it just adds 1 to the number that we've got. So if we now say we want to say power, I should do it from the drop-down menu really just to highlight that it's there, just there, power, and then we're going to say the number 2 to the power of whatever number that attribute currently is. And I think I'll display that number as well, actually, so we can see exactly what's happening. And we can then say, okay, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32. So it can be a very handy one to be using when you're wanting to demonstrate massive growth of something. Like if you were showing that every second every cell divided into 2, you could use power to do that. It's not your only option, as we'll see, but it's a very handy one. And if we want to, although I wouldn't advise it because it just makes things a little more confusing when you come back to it later, you can use, this way, can use the symbol there. So we then have the exact same thing. And you might recognize these numbers as we go through because they're numbers very familiar to us from device sizes and actor sizes and image sizes. Okay, so that's power basically. It's very simple, but very handy, very powerful. Now, the next one we're going to look at is log 10. Now, I'm not going to get into any detail really about what a logarithm is, but I'm going to show you what this does. Now, a good way to think about it is to think about earthquakes. We're probably all familiar with the Richter scale, and although this isn't quite how the Richter scale actually works, it's how most people think the Richter scale works. And it is with broad strokes. So if you have an earthquake that's a very small earthquake, it might be very low on the Richter scale. If we have an earthquake of 1, you're barely going to feel it. But if you have an earthquake of 2, it's going to be 10 times as strong as the one at 1. And an earthquake at 3 is going to be 10 times as strong, so 100 times as strong as the one at 1, and 10 times as strong as the one at 2. So basically, it's the number of times, and the number that you give it must be multiplied by 10 to get that number. So if we go back to our example and we say, and we'll put our number in. So we're looking at log 10, then the number. And if here instead we just say times by 10, and we'll start it off at 1 so that we actually have a number. So at 1, we've got, sorry, when we've got 10, you can divide that by 10 once. When you've got 100, you can divide that by, sorry, that's 10 times 10. It's very handy Spotlight, actually, because if you want to test things out, Spotlight's a great way of calculating them. So 100 is 10 by 10, so 10 to the power 2, and then by 10 is 1,000, by 10 is 10,000. So as we add each time, we've now got 1,000, that's 10 by 10 by 10, and then 10,000, which is 10 by 10 by 10 by 10. So very handy if you want to be taking a continually increasing number and condensing it down to a smaller point, to a smaller, more manageable number to be displaying to the user. If you want something every time it happens to happen 10 times as powerfully, you can work out how to do that with this one. Now, an interesting thing to look at is the relationship between power and log 10, because we looked at how power, if we want to say 10 to the power 2, to the power 3, to the power 4, etc., we can do that to get the number that we've just been using. But if we put the, sorry, I'll do this in one more. If we put the power inside the log 10, so we're saying 10 to the power of our number, and I'll change this back to +1. What should be happening is the one in the center here should be essentially cancelling out, the log 10 should be essentially cancelling out the power. So these two numbers should hopefully stay the same. So as we go up, not sure why we're, oh, sorry, we've got log 10 at the top there instead of power, no, yeah, so power, sorry. But, so every time we're timesing it by 10, we're dividing it by the 10 essentially. So you can use log 10 to work out how many times something has been has been multiplied by 10 to get to the number that it's at now. So you can use it, if you know the strength of the earthquake, you can use it to work out what number on the Richter scale it would be. And if you are using power, you can take the number on the Richter scale the earthquake is and work out how strong the earthquake actually was. So I hope that made at least vague sense. So that's log 10. Very interesting one, quite handy. But when we get into the really interesting bit is when we get into the exponential function, which gives a more natural growth than power. What's happening with power is every time, in fact, I'm just going to tab out to a guide that I'm going to recommend you take a look at, which gives a great explanation of this. I'll give you the link. But if we look at with the power, with power, every time we times it, we're having this one will then double, and we get the one green one. This time, each of them will be doubling, we get the 2, and so on. So what's essentially happening is every time we reach the next point at which the growth happens, the growth will happen all at once. And we won't be getting as it grows, it won't be affecting the result at the point at which the growth is measured. So that's a very poor explanation. You need to read this very carefully. It's very interesting bit of explanation and doing a much better job of it than I am. So with power, we say 2 to the power of 1 is 2, 2 to the power of 2 is 4, so it's just doubled. 2 to the power of 3 will be 8, so we've again doubled. So it's going up exponentially higher each time, but it's doing it all in one go. And what's happening in between isn't having any effect. With the exponential function, it is having an effect though. So we have a much more natural, smooth curve rather than jagged steps. Now, I think if you want to take the links, I'll leave them up for a moment, but these are just the shortened versions of them. I will post them tomorrow in the thread, and I strongly recommend watching. I think it's a great explanation. So if I go into game salad again, and if we now take a look at the exponential, we'll turn this one off. So we'll see that when we've got 1, it's using this Euler's number, which I'm really not going to try and get into, is well past me, which is a very handy bit of maths. It's an irrational number like pi, so it doesn't really have an end. And it's used in calculations like this to give us this nice smooth result. And so it doesn't look very smooth right now, but as you'll see in a moment, hopefully it'll become a little bit clearer when we look at a couple of examples. So as we keep going up, it starts growing exponentially, and by 10 we've gone from 2.7 to 22,000 in just 10 steps, and keeps going up like that. Now, if we put in a couple of real examples, it will hopefully make this a little bit clearer. So if I go back to this page where he's got a couple of examples towards the bottom, which I think really helped me understand it, so we'll have a quick look at them. So suppose you've got 300 kilos of crystals, and they're magic crystals because every 24 hours they will shed their own weight in new crystals. So every 24 hours we will have double the amount of crystals shed from the original ones. Now, if we use power, we will end up with just double the amount of crystals at the end of the hour. But if we use the exponential function, as the crystals are being shed, those crystals will also be shedding their own crystals. And those crystals will also be shedding their own crystals. So we get a continuous growth that is slightly higher than we'd get with POW, because the new crystals that are being shed off the old ones are themselves shedding crystals, so we're getting it growing faster than we would with POW, but also we get a much more realistic idea of how it's progressing. So if we start off with this 300 kilograms of crystals, we're expecting 6.6 million kilos of crystals at the end of 10 days. So if we go back to our example in the game, and if we say 300 times, so we've got 300 kilos each, this would be each kilo, we should, as we go through, see at the end of 10 days, we should have 6,600,993 kilos of crystals. So it's a really helpful one if you want to be demonstrating the spread of a disease or the growth of cells, and it gives a very natural result, a very natural curve to the growth and development. Now, like with POW, we've got an opposite of that, and the opposite is ln, which is the natural logarithm of the value. The natural logarithm is the logarithm to the base of Euler's number e. So we're basically having the exact same situation as with POW and, we'll just go back to these ones, and log 10, but with the exponential number. Now, this one is also very handy because it's very useful for doing things like, if we think about interest, as the interest is exponentially growing, we can work out, if we know the start balance and the end balance and the interest rate, we can work out how long it would take to get to that end balance. So if we are given an end balance and we know what the start balance was and we know what the interest rate was, we can work out how long it's been accruing that interest for. So again, very handy one. It'll just show you a few more examples if I started playing, and it can be very useful if you want to see, if you look at the result of something and you want to see, well, how long did it take to get to that result? How long did it take? If I know that I started with 300 kilograms of crystals and it's been 10 days, and I know I've got, sorry, if I know I've got started with 300 kilograms of crystals and I know it's now 6.6 million kilograms of crystals, I can work out that it's taken 10 days to get to that point. So these are slightly tricky ones if you're not a mathematician, but they are very handy. I have to say I haven't used them very often in games. I've used exponential function. I've never had reason to use the natural logarithm, But if you're doing any kind of game which is, as I say, looking at spreads of diseases, growth of cells, anything like that, they're very handy ones for looking at that. Square root. Again, I'm not going to look at this in any detail because we all know what a square root is. Gives the square root of any value greater than 0. Now, mod is one of my favourite ones because it is far more handy than people often realise it is. And there are very convoluted ways that people have come up with to do some very basic tasks, and then someone will come along and say, well, just use mod. I learned about mods from Arthur and showing some very concise and interesting ways of using it. We're going to look at just one today, but it can be very powerful indeed. And it will, if you give it a number, it will find the remainder after dividing it by the second number you give it. So if you give it, I'll go on to some examples. If you give it the number 10 as your divisor and you put in the number 100, it's going to say 0 because 10 divided by 100 is 0. And if you give it 101, 101 divided by 10 is 1. Remainder 1. So you've got the 10 tens, and then you've got 1 left over. 134 divided by 10, you'll have the 13 tens, but then you'll have 4 left over, and so forth. So it's a very handy one, and we can use it for very simple and very effective things like cycling through a series of numbers. And all we need to do that is say mod the number, the maximum number that we want to reach plus 1. So we just hop into GameSalad and take a quick look. Let's take some of these away. If I just enable this, so we've got number plus 1 down there still. So if we say, and I'll remember to use this to show today, mod the number, and I want it to count from 1 to 5. I want 5 to be the maximum number, and then just say plus 1. It's gonna, we would normally do this in a attribute itself and change or constrain the attributes, but we're just going to do it in the display text for now. I'll start it on 1. So start it on 0, sorry. We'll see that it will start off with 1, so the current value is 1. Then 2, 3, 4, 5, then it will cycle back to 1. And this is enormously handy for a huge swathe of things. For example, when I did my drawing template, I had the different brushes, and I wanted to be able to cycle through the brushes, and you can do that by assigning each brush a number and display whichever one the attribute is currently at, and they can just click to cycle through round and round. So very handy mod. You may have seen it written as a percentage, which, if I go back, which people will often use. So if you've seen a percentage in an expression in GameSalad, it's this mod function that it's using. It's recommended not to use a percentage, but I think that GameSalad gave up on trying to deprecate it because it would break so many projects. So you should be fairly safe using it, but it's better to get into the habit of using the proper function mod. So one of my favorite ones, and you'll find it very helpful in a lot of situations. So I'm just going to check the time, see how we're getting on. Okay, min. Now, this is, again, one that seems very simple, but when you start using it in your game, has incredibly powerful applications. So it will find the smallest in a given list of numbers. You can put as many numbers in there as you want. So you can have 50, 100 numbers in there if you want to, but you'll normally be wanting to do a comparison between 2. And max is the same, but it will find the biggest in the given list of numbers. So if I go into GameSalad, and we'll show you an example of a very handy way of using this. So I'm just going to make a box, if I spell it right, a box actor, and we'll make it gray. And I'm going to, actually no, I'll do this here. I'm going to tell it to be, I want it to be almost as big as the screen. So I'm going to say 468 and 220, and I'm just going to put in here the position I want it to be, which will be 284 and 160. If I drag this on the screen now and just set it into place. Now I'm going to try and say that I'm going to put an actor on the screen and I'm going to let the player drag it around. But I only want them to be able to drag it around inside this box. I don't want them to be able to drag it any further out than the edges of that box. So if I make this actor, and we'll call it player, and I'm just going to make it a bit smaller, and I'm going to say when touch is pressed, we're going to constrain the X and Y position to the touch position. So player position X and player position Y, and we're going to constrain it to touches, touch 1 X and touches Y. So now when I put this actor on the screen, when I'm touching it, it should constrain to the location of my touch, but at the moment I can take it anywhere. I can put it anywhere I want. So I know that this grey box is 50 pixels from the edge, from each edge of the screen. So if I go back into my player actor and I say I want it to always be at the maximum of 50 or the current touch position. So if I drag it off to the side, it won't drag any further because the lowest number that is assigned to its X position is 50. If the touch position becomes less than 50, it's still going to assign it 50 because we've told it to use the maximum of those two values. So now I can't drag it off that edge. I can still drag it off this edge, but I can't drag it off this side. If I go back in and I add a minimum as well, and I want the minimum to be whatever it is on that side, but I don't want it to be able to get closer than 50 pixels to the edge, to the right edge of the screen. So if I'll just use display size here, and then I say display size minus 50. Now what I'm saying is I want it to pick the minimum of the touch X position and 50 pixels from the right, sorry, from the left of the far edge of the screen. So now, if I've done that right, I shouldn't be able to drag it any further this way. And I shouldn't be able to drag it any further this way. So combining the two, I've now limited where the actor can go. I'm looking at the time, and I'm not going to show you on the y-axis as well, but you can just apply the exact same logic. What is interesting to do, though, is to try and say, well, hold on a second. At the moment, I can drag it out of the box. I can get it halfway out because these are always happening from the center of each actor. So it's the center of my actor that can't go any further than 50 pixels. So I know that the actor is 30 pixels wide. So I can say plus 15, which is half its width, or I can just use its actual width and say size width divided by 2. So now I shouldn't, if I've done that right, be able to go any further than that edge of the box. And you can do the same on the other side and the top and the bottom and limit it to entirely in that zone. So minimum and maximum, both very handy. You'll make good use out of them. If you're not using them already, there is bound to be a time could turn up soon when you're going to need to use them. Okay, magnitude. Now, magnitude will essentially find the distance between 2 points. And the way you'll typically see it, although it doesn't have to be quite like this, as I'll show you in a moment, is the magnitude 0.1x minus 0.2x, 0.1y minus 0.2y. I'll explain to you what the two values and the minus are for in a moment, but it's very useful for finding how close you are to an enemy. So you might want to have a turret that only fires when you get within 20 pixels of it, or 50 pixels of it, and so you can use it to monitor how far away the two things are and take action accordingly. So if I just look to have a quick look at, let's delete these off out of the way. If we make a new actor, we'll call this the player, and we'll make a new one and call it the enemy. And I'm just going to put the enemy, what should have done, make the enemy much smaller. Let's make it 15 by 15. It's only going to be very little. And 284 by 160. So we've got the enemy there in the center of the scene. Let's have the scene, oops, nice color. Let's make it an orangey color. Now, with the player actor, I probably shouldn't have deleted that last one thinking about it, but we'll soldier through. We're going to need to do the touches pressed again so we can move it around. I'm just going to constrain it to touch position again. This is when we should also, my cat's now appeared. She's trying to kill something. I'm not sure what she's got now. She's bloodthirsty tonight. Oops, no, that's not right. And I'll just plonk the player on the screen. And so now I should be able to pick up the player and move it around. So let's say I want to fire at the enemy when I automatically fire at the enemy when I get within 100 pixels of it. So what we're going to say now is, actually we're going to need a bullet actor. We'll make an actor called bullet, and we'll make it blue just because, and we'll make it only very little. So now we're going to say when numeric expression, we're going to pick magnitude, which is here. Now, when we use magnitude, if I put in here player position X, player position Y, and what I'm saying is that when 0, 0, so X 0, Y 0, we're going to compare X 0, Y 0 to the self player position X, player position Y, and see the distance between those two things. So that's not going to get us the result that we want, because if we haven't put a second value in here on each side of this comma, it's going to assume we're talking about the position of 0 on the x-axis and 0 on the y-axis, which is the very bottom corner of the screen. So if I just put the display text in, so if I move this around, we should see when oh no, that said 0, we want 100 here. When I get within 100 pixels of the bottom corner, it should, no, it's not display text, or it says equal, so we want equal grades to, hopefully we'll get it to display. I've done something wrong somewhere. Your expression is right there. Well, I'm going to learn from previous. I'm not going to try and troubleshoot a minor issue down to the ground. It's nearly 2 o'clock in the morning. If I haven't seen it straight away, I'm not going to see it. So what we're going to do instead is we're going to look at the center actor, the actor in the middle of the screen. So if we say, so that's 284 on the x-axis and 160 on the y, we could record the enemy or the enemy's position and put it in game attributes and refer to those, but we're not going to do that now. And in all likelihood, you'd probably want to be putting this behavior in an enemy and having the enemy do something when you got close enough. So in that case, we'd be constraining the player's position to game attributes. And if I then put minus the player X and minus player Y is less than 100. Oh, that was what the mistake was before. Never mind. We should see when it gets close enough, hello world. Now, as I drag it around, you'll see that it's a kind of circular shape. And that's because it's always looking at 100 pixels in any direction. Wherever we are, it's looking for when we're 100 pixels away. So if I, instead of displaying a display text, tell it to spawn a bullet, every time I am getting that close, it should spawn one of these bullets. I'm having to go in and out because the rule's only firing And they're not entirely in a circle because I'm moving it quicker than the game can keep up with. You'll see we're getting a broadly circular shape going on there. So anytime you want to tell the distance between two actors, the magnitude function will help you to do that. And if I swap these over, at the moment it's actually doing it the opposite way round to what we would probably want in an actual game. The moment it's looking at it from the perspective of the center actor rather than the player actor. So let's just swap that over. And so now, there we go. As we come in and out, we're still getting that more or less circular shape. If I want to only look at it on the x-axis or the y-axis, I can use magnitude. I'd probably be better off using abs, but I can use it. And if I just put 0 on that side, it should now only do one above and below. It doesn't care how far I go in either direction. All it's interested in is when I am vertically 100 pixels away. So very handy in a huge swathe of ways, magnitude, and you'll use it all the time. So let's make our bullets actually fire at the enemy. So we're going to make them move. If I just put a move behavior in, and now rather than them just appearing, they should now fire off. Oh, I've got it the wrong way around again. Oh, so we want it was 284 on the X and 160 on the Y. Why am I'm only getting them firing? Oh, because I haven't told it to fire more than one bullet. So we'll just say every 0 second. Oh, I've just changed it around again. The moment it's doing it when you're more than 100 pixels away. But I'm not going to bother changing that because I've already butchered that enough. So if we have it firing these bullets, at the moment it's just firing bullets, and the bullets are immediately moving to the right. And they're not firing at the center, the enemy actor that's sitting in the center of the screen. So if we want them to do that, what we need to do is we need to make use of another very handy function, which is vectorToAngle. And this will find the angle between 2 points. So if you've got the actors in the center of the screen and our player actor, it's going to find the angle between the two of them. So if we have it directly above, we'd be looking for it to give us the angle from the player's perspective to the center of the screen. We'd be wanting it to give us the angle of 270. And if we had the player directly to the left, we'd be wanting to get the angle of 0. So it's very useful for finding the direction something needs to travel to move from that first point to that second point. Oh, we're getting ahead of ourselves there. And I'll try and very quickly, and I'm not being all that clear on my explanations in Game Salad as we get later and later, but I'll try and not butcher this one too much. If we put vectorToAngle in here, and again, we're going to be wanting 284 minus player X, comma, 160, which is where the enemy is, again, minus a Y. And now they will fire the bullets at the center of the screen. Wherever we are, it will work out the angle the bullet needs to, the angle we need to spawn the bullet at in order to point it at the center of the screen. So vectorToAngle, again, super helpful, very handy, well worth the time to spend some time getting to know and understand and to use. So now on to the more complicated part. We're going to look at sign. Now, it is sign, there's an E on the end when you write it properly. I've put it as you see it in the game. And essentially, what this is going to do is it's going to give us some fun ways of moving things. There's a lot of interesting maths behind it. It's all related to circles and to angles, and there's more than I want to get into at 2 o'clock in the morning trying to explain that. There are some great tutorials available. I'll try and put some in that thread tomorrow that will help you understand the maths behind it. But as far as we're concerned, we're going to look at how we use it in the game. So I'm going to take this one off. I'm going to stick with our player actor. Let's get rid of those so I don't confuse myself. And all we're going to do to start with is we're just going to display some text. We're just going to display game time. And I'm just going to show you this so you know what we're working with, first of all. Because when we're using sine, cosine, and tan, but I'm not really going to go into tan, I'm not going to touch on tan today. And when we're using sine and cosine, it needs a value that's constantly changing. So time is a great one to use. As you can see, all it's doing is it's just ticking up the seconds as we go along. So if I put sine time and display that again, what you'll see is if you look at this first digit, it's slowly counting up towards 1, and it's doing it very, very slowly. And if we go back in and we add an extra multiplication, let's times it by 10. So it's now going to be happening 10 times as fast because we've times the time by 10. So instead of 1 second, it's seeing 10 seconds. And as you'll see, it's going up to that 1. As it reaches the end, it slows down and then comes back down again. And now it's going to go all the way back down to 0, and it's going to carry on until it gets to -1. So what we've got now is a number that's going from 0 to 1, then back to 0 and to -1, then back to 1, and then so on and so forth. Now, what makes this quite helpful is if we do something like constrain attribute, and we say player position X, and we put this in here, and we say in time, and we'll times it by 100, and we then need to give it a starting position. So the position that, because at the moment it's going to put it on the, I'll show you actually, it's going to put it on the far edge of the screen, and nothing's really happening. First of all, you'll see that it is moving, but it's only moving a tiny bit. So if we, first of all, say 284, we're going to say that's that center point, and it's going to now be doing the same thing in the center of the screen. But as you can see, although it is moving, it's only moving a tiny, tiny amount. So what we're going to do is we are going to multiply it by, let's say, 100 again. So now we're going to see 100 times as much movement as before. And now we've got an actor. I'll turn the display text off. Now we've got an actor that's oscillating from side to side, which is very handy in itself. So if you've got a platform you want to move backwards and forwards, you might want to have it moving using sine, and it's just going side to side, side to side. All cosine actually is the same but the opposite way. So you could be using cosine here as well. That would be perfectly reasonable. We're going to be using cosine for the x-axis when we look at that. So what we've got then is a formula. In fact, I'll go back to where I've written it here. So what we've got is a formula where we're saying sine, the time, which is our changing number. You can use something else. You can use an attribute that you're changing yourself. That will work as well. Times the speed we want the change to happen at, the oscillation to happen at, multiplied by the distance we want it to travel, so the amount we want it to oscillate by. So when we say times by 100, we're just saying, instead of it being 0.1 to minus 0.1, sorry, we're saying, let me show you that actually, let me get the display text back up. If I just show you the display text again here, at the moment it's going 0.2, so it's going to 1 and -1, but via very small increments. If I times that by 100, you'll see that now we've got it going all the way up to 100 and down again. So what we using is these elements then. Time, speed, distance, starting position. Some people put distance in front, do that multiplication in front. Because of the order of operations like we talked about before, it's going to do the multiplication before the addition here. So these are going to be multiplied whichever side of the sign you put the distance times distance on before the addition is added afterwards. So cosine is essentially the same thing. If I change this to cosine, for our purposes in game, we've got it. It's just moving, starting in the opposite on the opposite side. So if I change this as well, we just have it going the opposite way. They're not working at the same speed, the number and the text, so don't worry about that. And then it will go down and so on. So what we generally use them for is we want to, instead of having this one on the X, we'll put it on the Y. We'll have sine on the X. So now what we're doing is we're moving them both, hopefully, let me just double check, at the same speed. This needs to be 160, so it's in the center there. Moving them both at the same speed, oscillating them backwards and forwards, and the end result of that is a circle. Because as we're moving across on the x-axis, we're moving down on the y, and then moving across the other way on the x-axis, we're moving up on the y. So there's a good little GIF which I'll put in the thread tomorrow as well, which I forgot to put on the presentation, that shows what's happening with the circle that causes this wavy motion, this oscillating motion. But again, that's the maths that I don't really intend to get into. But what I will show you is a slightly more thorough demonstration of what's really happening with these two and how we can combine them together. So if I just take, actually no, I'll leave that on so you can see the things. So if I I want it to move very quick on the horizontal axis, and I don't want it to move at all on the vertical axis, and I want it to move 100 pixels outside, so there I've just got it oscillating backwards and forwards. If I increase the distance, it'll oscillate more. So all we're doing is increasing this number here, the distance number. If I increase the speed number, so this number here, it'll do it quicker. We can get it happening nice and quickly. If I just put these back to 200, if I make it happen on the y-axis as well, we should see we get that circling motion again. And there we go, it's just going in a nice circle. Now if I want to stretch out the circle a bit and have it moving in a more of an oblong shape, I can increase the axis, the distance it's traveling on the X or the Y, so it's traveling further on the X for the same amount of time on the Y. If I want it to go into more of a right egg shape, I might increase the vertical distance. And I'm really not seeing quite all of it here. Let's just, that's too small, I'll hide this. This should give us just enough, there we go. So it's nice oblong there. I can really mess these around and say, okay, well now it's going to move slower on the horizontal, but it's going to move at the same distance on both. So now what I get is a kind of weird zigzaggy. And if we let this run for a moment, you'll see that, there we go, now it's met up and it's doing the same pattern again. So we're getting a weird zigzaggy pattern. If I decrease the vertical speed, it will do, oh, I've got almost an egg there, but it's not quite making it around now, it's looping back around. So you can have a play. I'll put this file as well in the thread for you to download and have a play with. So basically, if you want to move something in a weird wavy motion, you're likely to be able to find a way of getting sine and cosine to work for you. Now, if you browse the forums a lot, you'll see that SOX does crazy magical things with these functions, and there's almost nothing that he doesn't seem to be, he seems he can't do with them. He's far more proficient at them than I am. I basically just work out what I want to happen, and then figure out, well, it's got to be this and this and this, and trial and error until I get it quite right. But let's just do slightly lower horizontal distance. Let's increase the vertical speed a bit. So that's basically sine and cosine. All you're really doing is you're taking an oscillation to the left and right, an oscillation up and down, and telling it how far to move, how fast to move, and making use of the results. And it's a great way of getting good enemy motions, patrol patterns. If you want to have a bunch of enemies follow each other in the same pattern, you can do that. You can give them the same function, same sine and cosine values, and they will move. Move in the same way. So very handy way of. I'm just going to put this back to 0 and show you again the up and down. So that's all that's really happening. Is it's being told to go up and down. We can define exactly how much, and we can define exactly how fast. Then if we add some horizontal distance, it's just going to be moving at the speed we tell it to, backwards and forwards on the horizontal as well. And that's all it really is. It's all the mystery of sine and cosine really is a combination of back and forwards on the x, up and down on the y, and the distance and speed that we tell it to move. Now, I had hoped that would be a bit clearer and more coherent than that, but hopefully you've got a decent idea. And I'm going to push on. I think we've got only a little bit to cover on. Look at the time. We've been an hour now, so I'm going to push on very quickly now to the last couple of things I want to mention. If you've got any questions about sine and cosine, I will try and answer them, but I'm not the best person to necessarily do so. You've got far better people at using them on the forums than me. I just get them to work as best I can to get the result I want. The mysteries of them, the mysteries of the maths behind them, I don't understand anywhere near as well as I'd like to past what is essentially happening. But I want to show you one final thing, and that is conditional logic. And I did a video on conditional logic, so I'm not going to look at it in any particular detail now. I didn't want to talk for more than an hour, so I'm going to just very quickly show you an example and then direct you to the video that I made. And there's another couple of videos I intend to make on the subject that I haven't got round to yet. And we're going to say number, and we're going to say the number is 10. And all it is if I make a rule and I say if attribute number equals 10, display text true. Oh, help if I put true. Actually, I won't use true because that sounds like a boolean. I'll say yes. And so, oh, definitely need to put it on the scene. What I should see is, oh, I've got that hello world one, sorry. Tell I'm getting late now. Is it'll say yes, because the attribute is equal to 10. But we can save some time here, and we can avoid this whole rule and do all that we need to in the expression editor. And if we open a bracket and say number is equal to, we need two of them, equals to 10, and then we put and say yes, we should now see the same result. And it's basically just a way of skipping out some of the rules, some of the graphical elements of GameSalad to speed things along or to condense things down. There's been some discussion, we had a bit of a discussion about if it would actually save any processing time when you run your game. My understanding is that it won't, because all you're doing is going a different route to the same place when GameSalad compiles the game. When it compiles the game, it's going to give you a game that's made from C or some language. I'm not sure what they actually program it, C++ or something, whatever they program it in. Not actually what we do in in GameSalad. They're converting what we do in GameSalad to the code that the phone is going to actually be able to run. So how you tell it to get to that point of converting, I don't think should make any difference. But the GameSalad guys will be able to tell you if it actually does make a difference, if there is any runtime benefit to it, but I don't think there is. But now let's just add an extra condition here, and we'll say, well, okay, so if the number's 10, we're going to display yes. But if I put 11 in here and we play it, it's going to say false because it's not equal to 10. So we don't want it to say false because that's not, it doesn't look very professional. So we're going to say or, and we're going to put no. So it's now saying if the number equals 10, display yes, or display no. And so it's now, because it's not equal to 10, going to say no. And all that's doing is the same as opening that otherwise up, dropping a display text in and saying no. Now there's huge amounts you can do with this, very powerful, very helpful. I found it particularly useful when I was trying to make a multi-touch template because I could have it check through all the different touch numbers all in one change attribute without having to do if touch 1 is true, if touch 2, otherwise if touch 2 is true, otherwise if touch 3 is true, etc. I can do it all in one change attribute. So very helpful, very good way of saving time. You can stack them, you can have multiple conditions, you can have great big lists of them that I go into in a lot more detail in my video and more clearly as well. So that's essentially then the expression editor, the key main functions that you can use to do maths-based things. There's a lot you can do with text as well, and it's enormously powerful in the text with the text functions as well. The only thing, there's a couple of things I'd like to see it do, which I'll submit feature requests for when I get around to it. But being as we've been over an hour now, I'm not going to get started on the texts, and I'll have to talk about those another day. I'll make a video on them or something like that. I intend to go through each of these functions in a separate video and explain them a bit more clearly with a bit less rushed, with a bit more conciseness, which I will hopefully be putting up on the Academy if I can get it all done. But I'll be sticking up on YouTube as I go through anyway. So if there's something that I've looked at today that I've gone over too quickly or I've not made enough sense on, because I'm now at 2:17 in the morning, so I'm not going to be making much sense, then I'll be doing videos on them that will hopefully be a bit clearer. So that's all I'm going to talk about tonight. If you have any questions, I'll be happy to try and answer them, as long as they're not super maths related, in which case I probably won't be able to.